So let's continue further. What we had studied in the last lecture was Gauss law. So I'll just write down the equations. So there were two forms, right? Integral form and point form. So first law was Gauss law for electric fields. So what was the equation? Closed surface integral of d vector dot ds vector equal to q enclosed. And in point form, after applying which theorem? Divergence theorem, we got it as del dot d vector equal to rho v. And what is rho v? Volume charge density. Again, units are important for this course. What is the unit? Coulomb per meter cube. What is the unit for d vector? D vector is what first? It is electric flux density. And what is the unit? Coulomb per meter square. And now you state this Gauss law. From this equation, you should be able to state the Gauss law. There is no need to buy out. So from we had understood what is the meaning of this integral. Now if you have observed, I have given a single integral instead of double integral. Why? Because I am giving one integral and I am writing s. So it indicates a surface integral. If you don't want to write s, you use this symbol. Even if you write s here, it is fine. But if you are writing a single integral and you want to mention it as a surface, it is compulsory to give s. Similarly, if you want to use a line integral, use L. Or if you don't write L also, it is fine, because in a way it is a single integral. So again, what is the meaning of this integral? It indicates the amount of electric flux density, that is the amount of d vector coming out of what? The second vector, that is the surface. So how is it this equation is read as? The total amount. Why total? Because of this integral. This, if you say only this, it is for a small part. So if you remember, we had taken a hollow window and we assumed it is infinite in nature. So we said we cannot find the area directly. So what we do? We divide it into very small parts such that each part is dx and dy. So then what we do to find over the entire thing, we integrate dx dy. And then we said since it is hollow, let's assume some air is passing through it. So amount of air passing through a small portion is what? Dx dy. So what is the total amount of air passing through it? It will be integral of dx dy. And air we indicated by a function f of x. So the total amount of function f of x coming out of the surface, that is the total amount of air coming out of the surface or going inside the surface, is what? And double integral f of x dx dy. So dx dy is surface, so that is what we have written, and our function is d vector in this case. And what is in, so function was air, now function is what? Electric flux density. So how we read this? The total amount of electric flux density coming out of the surface is always equal to the charge enclosed by what? Obviously the same surface. So then we had Gauss law for magnetic fields. So how is it read? Again, surface integral of b vector dot ds vector equal to 0. So applying divergence theorem and solving it, what we get? Sorry, b vector del dot b vector is 0. Now some might have a doubt that if you have not attended the last lecture, why is not current here? Because magnetic fields are usually associated with current. We said instead of electric charge we have a magnetic charge, and we argued that for a magnet we have a north pole and south pole. If I break it into two, I cannot separate the magnetic charge, always of north pole and south pole, right? So since because of that I get 0. So the total amount, so how you read this? The total amount of magnetic flux density coming out of the surface is always equal to 0. Because why? Because we cannot have isolated magnetic poles. You always have a magnetic monopole. That is, sorry, we cannot have a magnetic monopole. We always have them together. That is, we have the north and south pole together. So since we cannot separate them, this is 0, right? So next, further we'll have some more equations. So these are 4 equations so far total. So let's see what is the next topic. So next is Ampere's law. So I'll make a change here. I'll first write the statement. So the statement says the circulation of the magnetic field intensity. What is magnetic field intensity? Denoted by H vector. The circulation of the magnetic field intensity H vector about any closed path is equal to the current enclosed by the same path. And what is circulation of H vector? It is defined as, that is, the circulation of H vector is defined as the line integral of H vector over a closed path small c. So we write it, it is a closed path, so closed path is c, so that c, or it is also called as contour integral H vector. Since it is a path, so it will be a line integral, so dl vector equal to, it is equal to what? Current enclosed by the same path, so I enclosed, right? So what does this mean? If I have a current carrying conductor, so it is carrying a current in the I direction, so current enclosed, so the total amount of circulation of magnetic field about any closed path. So what is this indicate? So this is the circulation of magnetic field. Magnetic field is always in loops. So this is my H vector. So the circulation of the magnetic field intensity, the circulation of the magnetic field intensity H vector about any closed path. So this is my closed path is equal to the current enclosed by the same path. So inside this, what is the current enclosed? This is the current enclosed. So this is what I enclosed, right? So this is what is the meaning of Ampere's law. In other simple layman terms, what does it mean? If I have a current flowing through a conductor, it will always generate a magnetic field around it. So what is the meaning of Ampere's law? What you have to understand? If I have a current carrying conductor, it will generate a magnetic field around it. The direction is given by what? Right hand rule. So let's say this is my current carrying conductor. It is pointing towards you. Current is flowing towards you. So my thumb points in the direction of current. So my curled fingers give the direction of magnetic field. So how will it move? It will move like this. Okay. So again, this is which form? Integral form. So I want point form. So what I do? This is line vector. So in the last lecture we have seen we can apply Stokes theorem. So we write by Stokes theorem. So what will this become? Line integral gets converted to surface integral and we get cross product. So del cross H vector dot ds vector equal to, I can now, since this is a ds vector, I have to write this in ds vector. So if you remember, q के लिए क्या लिखा था? Q is volume integral of rho v dv. So I should be what? Surface integral of ds I want, right? So it should be what? This is meter square, this is ampere. So I want a unit ampere per meter square. So I write J. J is what? Current density. Unit is ampere per meter square. And both are vectors. So dot product. Why dot product? Because I want a scalar. We know dot product output is scalar. So it is J vector dot ds vector. So this is surface integral of J vector dot ds vector. Okay. So again we cannot solve this directly. So we write del cross H vector minus J vector dot ds vector equal to 0. So what will get? Del cross H minus J is 0. So what will get? Therefore del cross H vector equal to J vector, right? So this is my point form of Ampere's law, right? So again, we have got the next form. So Ampere's law. What is the integral form? Closed contour integral of H vector dot dl vector equal to I enclosed. Now what is the point form? Del cross H vector equal to J vector, right? Then after this we have Faraday's law. So you already know what this law is, so I will not write this statement. So Faraday's law. What does Faraday's law? What is the equation? EMF is minus d phi by dt, right? So this is the equation for Faraday's law which you have studied. But as you see, we are in electromagnetics course, so we talk about electric and magnetic fields. So vectors are very important. So somehow we have to change this to vectors, right? Before that, what is the statement? What does it state? Whenever I have a, let's say I have a coil. So this is just a open wire, and I keep a magnet here. It is not pulled like this. So what will it do? It will generate have a magnetic field influence over here. So when I move the magnet like this, suppose this is my magnet, so if I move it like this, what will happen? A magnetic field will cut this wire. So what does Faraday tell us is that whenever a magnetic flux gets linked with the coil, it generates an EMF around it. So that is what is the meaning of this, and this wire will try to oppose the EMF generated. So because of that we have a minus sign. So this, since you already know this, I will not go into details. So what is E? It is nothing but voltage. So what is the unit? Voltage, right? So now we know electric field, one of the formula is V by D, where D is the distance, because we know what is the unit of electric field, volt per meter or newtons per coulomb. So I am using this formula. So V by D. So what will be V? That is E in this case, E into D. So I'll write therefore E into D equal to minus D by dt. Oh, now what is phi? Phi is magnetic flux. So it is given as what? B into A, where B is what? Magnetic flux density, A is the area. So minus d by dt of BA. Now just we'll write converting in vector form. So what will we get? So this will become an integral now. So surface integral of D vector, sorry, D is what? Distance. So it is a line integral. So closed line integral of E vector dot dl vector equal to minus surface, I'll keep d by dt for timing. B will become B vector dot ds vector, right? And it is variation with respect to time. First thing, why does time come into picture? Because if you are moving the magnet, you are moving it with respect to time. The speed and all those things come into picture. So time comes into picture. So that is why time has come here. So it is rate of change of magnetic flux. So here we write it becomes dabba by dabba t. Why it becomes dabba by dabba t? Because it is a vector now, right? So it is dependent on both these quantities. So that is the reason it becomes a vector. So closed integral of A vector dot dl vector equal to minus dabba by dabba t surface integral of B vector dot ds vector. So what is this? My Faraday's law. Which form is it? It is integral form, right? So now I need to convert this to again what? Point form. So what I do? I use Stokes theorem. So I write by Stokes theorem. So what will this become? Surface integral of del cross E vector dot del cross E vector dot ds vector equal to minus dabba by dabba t surface integral of B vector dot ds vector, right? So again I can take this minus dabba by dabba t inside. So I can write, so therefore del cross surface integral of del cross E vector plus dabba by dabba t of B vector dot ds vector equal to 0. So therefore this term is 0. So after solving, what we will get? Del cross E vector equal to minus dabba by dabba t B vector. So I finally get this equation. So this is what? Point form of what? Faraday's law, right? So again we can further write in this table. So it is closed line integral of E vector dot dl vector equal to minus dabba by dabba t surface integral of B vector dot ds vector. And what is the point form? Del cross E vector equal to minus dabba by dabba t B vector, right? So let's go to the next part. So it is continuity equation. continuity equation. Okay. So again, I am not writing all the assumptions. Whatever, we always start with what: consider a point charge placed along the z-axis, or consider infinite line charge placed along the z-axis at the origin, having a uniform line charge density of rho L coulomb per meter, and so on. So that I will not write. For that you can refer notes which I will upload. So let's say again we write some assumptions to arrive at this equation. So first assumption is, we consider a closed surface which is having charges of q coulombs distributed over it. So let's say this is my closed arbitrary surface of any shape. So it is denoted by ds, and it is having charges of q coulombs distributed all over it. Okay. So now what will happen as time passes? If I just keep this surface, the number of charges will be decreasing over time, right? So therefore the current will be what? We know the current, it is given as what? dq by dt. It is the rate of change of charge. And since the charges are decreasing over time, it will be negative. So again, how will you come across this derivation? This is an important question. It is asked in the exam for 5 or 10 marks. Derive the expression for continuity equation, or what is continuity equation. So I will write the assumptions. What we started with the assumption, we'll write consider closed surface, or consider a closed surface having charges of q coulombs distributed over it. As time passes, next we'll write, as time passes, the number of charges will be decreasing over time, right? Then therefore the current is given as I equal to minus dq by dt. This is what we have assumed, and you first draw the diagram, right? So next, what do we see? I can write q in terms of what? Volume integral, right? So I'll require I, and what is I? I we saw in a while ago, it is closed surface integral of j vector dot ds vector. So minus d by dt. So we saw it becomes dv by t, volume integral of rho v dv. Right? So again, why it becomes a partial integral? Because dv is what? Dx, dy, dz. So it is not dependent on only one variable. It is dependent on two variables now. Again, the same thing here. I don't remember whether I told this. So I tell it. Here it was what? E dot d is minus d by t b into a. So why did it become dv by t? Because it is ds vector. Ds vector can be dx dy. So it is not dependent on one variable. Here it was dependent only on one variable. Here it is depending on two variables, for example x and y. So that is the reason it becomes dv. So now since this is a volume integral, this is a surface integral. So what do we do to convert it to volume integral? We use divergence theorem. So by divergence theorem, this will become volume integral of del dot j vector. So del dot j vector dv equal to minus dv by dv t, volume integral of rho v dv. So again we will take this here. I will not write that step. So what we will get? Del dot j vector equal to minus dv by dv t rho v. So we get del dot j vector equal to minus dv by dv t rho v. So this is what our required expression. It is called as continuity equation. Now the thing is, why is it called as continuity equation? So again, I always tell my students, there is some reasons why all the equations are called in this way. There is always some history or some story behind it. So why is it called as continuity equation? Is, let's say it is a static field. So static means what? It is not dependent on time. So this will be 0. So what will we get? Del dot j vector equal to 0, right? So what does it indicate? Divergence of j vector is 0. Now what is divergence? Divergence indicates what? Something coming out of from a point. So this is the divergence. What is this divergence? It is positive because it is, everything is coming out. So if I take a cube, and if something is going like this, so it is entering as well as exiting. So divergence will be what? 0, because something is entering as well as exiting. So here the divergence is positive, here it is 0. And if something is going inside, it is negative, right? So what you can say, what is j vector? Current density, right? So the what does it indicate? Del dot j vector is 0, means something coming out of the point in this case is 0. And what is that something? It is current density, right? So what is indicate? It indicates a very subtle, very simple equation we have studied in your first year. What is it? Just think over it. Something which comes out from a point is always 0. What is it? So I take a point, so I draw some arbitrary lines. So I say, I just said this is positive, so it can be a combination also. So I say some are incoming, some are outgoing, right? And let's say, what does this indicate? It represents what? Which diagram? KCL diagram, right? So sum of incoming currents equal to sum of outgoing currents, right? So something coming out is what? Always 0, right? So that is what it is indicates. So it indicates what? KCL. So so continuity equation in static form indicates what? KCL. Why? Because divergence of j vector means something coming out of a point is always 0. That is summation of all the points of all the currents coming out of a point is always 0. That is nothing but what? KCL, right? Similarly, we can prove KVL also. That we can prove using which thing? Using this equation. KVL is what? Summation of all the voltages and the product of current and resistance is 0. So if you see E, we saw E is what? V by D. So what is voltage? It is E into D. So this is nothing but E into D. DL is distance. So this summation again is static form because DC source is static, independent of time. So this is 0. So this indicates what? KVL. Right? So that is why I say, if you have seen my first lecture, I have said electromagnetics is the mother of all subjects, and I prove why it is called as mother of all subjects. So this is the first thing which is aiding me to tell that it is the mother of all subjects. So all electronics, BEE, your network theory or circuits and transmission lines, whichever subject it was called as, have propped up from, I can say, electromagnetics. So they are special cases of this course. So this is a very important and fundamental course. Okay. So this is what? Continuity equation, right? But there is one problem. So what is that problem? We'll see in the next lecture. Okay. So just try to find out what is that problem. If we are able to find out, just post in classroom. So it will be interesting to study in the next lecture.